Dear students, I am Dr. G. Ramesh Kumar, Assistant Professor, Department of Computer Application. Today's video lecture class is Cryptography and Network Security. Actually, in this Cryptography and Network Security, we have taken the topic called Rse Algorithm. First of all, we will see how this Rse algorithm how much it is useful for us. First, I will tell you why we are using this Rse algorithm. So, before coming to this explanation of this Rse algorithm, I will tell you the objective of the actual meaning, objective of this problem. Actually, when we are sending a file containing of some important valuable information, that file is going to be sent from sender part to receiver part. Sender is in one location, receiver is in another location. So how we are sending these files from sender to receiver? Usually through online only we are sending. While we are sending this file through online, there is a situation that some third party intruders, or we can say hackers can capture these files and they may utilize the information, I mean the content of the file, or sometimes they may damage the information and they may resend the file to the receiver. But the receiver may think that the file was sent from sender part. He doesn't know that the file was captured by intruders, or we can say hackers. So to avoid this problem, we are going to use the technique called encryption and decryption. What it means? Encryption is going to be applied by sender side. The decryption technique is going to be applied in the receiver side. First thing is encryption. First I will tell you the meaning of encryption. Encryption is nothing but the actual content of information is going to be replaced with any other data, so that the data is going to be in unreadable form. So while we are changing the content into unreadable form, automatically the hacker, even though the file was hacked by hacker, he cannot understand what it means. The meaning of the content will not be understandable by the hacker. So that is what we are going to change it into another content. That is what called encryption. So when we are doing this encryption, usually the public key is going to be used here. So this algorithm, Rse algorithm, what it means, Rse means there was three scientists. One name is called Ramesh, Adi Shamir and Len Adelman. These three scientists have combinedly invented this Rse algorithm. That is what these three names first letter can be used as Rse algorithm. Actually, this Rse algorithm is most widely acceptable and implemented for the purpose of encryption method. So actually these three scientists have invented this Rse algorithm in the year 1977 at MIT. Actually the specialty of this Rse algorithm is applying of block cipher method. Actually block cipher is the original content, the information that is called as plain text before applying the technique called encryption. After applying the encryption technique, the plain text has been converted in the form of ciphertext. Ciphertext is nothing but unreadable data. Plain text is readable data. When we send the information in a plain text basis, automatically the hacker can understand what is the content of the file. While we are sending the content with the encrypted manner means automatically it has been changed into ciphertext. Then the ciphertext, he cannot understand anything with the message. Okay, so that is what this ciphertext can be ranged between 0 to n minus 1 for some n number of informations. Usually the information size going to be used with 1024 bits. We know that 8 bits is nothing but 1 byte. So I am taking one example called 1024 bits of information. So that how many number of bytes going to be encrypted. So it is nothing but 309 decimal digits. It is nothing but the total n number of size information which is lesser than 2 to the power 1024, because the block size is 2 to the power I. Here I is n which is lesser than 2 to the power I plus 1. So with this background of this information, now I am going to explain this RSE algorithm by using of encryption and decryption techniques. Actually, this RSE algorithm, we have encryption, we have one formula, and for decryption technique also we are having another formula. I already told you, while we are doing encryption technique, our plain text is going to be converted in the form of ciphertext. Ciphertext in the letter, in the word, we have the first letter called C. So ciphertext is nothing but C. But the ciphertext, by doing encryption, the ciphertext was originally the message. Okay, the message is nothing but M. So the ciphertext is equal to M to the power of E. E is nothing but encryption. Actually, I am going to do this calculation by modulation. Modulation of N. N is nothing but the total size of information. So modulation means I am going to divide with the left hand side of the value with the right hand side of the value, so that I will get the value of encryption. In the same manner, I am going to do for decryption technique also. Actually, in decryption, while we are doing decryption technique, automatically the procedure of encryption in the reverse basis, so that the what we encrypted the content going to be decrypted. If we do decryption technique, automatically the original text, I mean the plain text, will be received. So ciphertext is nothing but decryption. So I have to apply decryption technique, so that M equal to C to the power D. M is nothing but message, C is nothing but ciphertext, D is nothing but decryption. I am going to do this decryption technique for the whole n number of information. So that is what the formula is called, used for decryption is M equal to C to the power D modulus of n. So actually for encryption E, I am going to do this for the n number of n size of data. And for decryption, I am going to use one private key. Actually, encryption is going to be done by sender side. Decryption is going to be done by receiver side. So that is why public key is E, N. Private key is D, N. Actually, to do this RSE algorithm, what are all the requirements we need to solve this problem? Any or their values e comma d comma n such that m to the power ed equal to m of modulus of n for all m. Here this meaning is we know the value of c, m, e, d, n. For all these variables we have the values. So these values are going to be substituted in this formula for both the encryption as well as decryption, so that we will get the value of encryption in the left hand side. Also we will get to the value of decryption in the right hand side. Okay, so with this basic idea I am going to explain with one small problem. In this example problem I am taking the same formula c equal to m to the power d modulus n. So actually c is nothing but ciphertext. How we are getting ciphertext? While we are doing encryption, automatically the plain text is going to be converted in the form of ciphertext, so that the message is going to be encrypted. So the value of m is nothing but message size is 2. So the encryption value is 7. So 2 to the power 7 modulus of 33. 33 is nothing but the total size, n size. Okay, so now we'll have the equation called 2 to the power 7 divided with 33. Okay, 2 to the power 7 is nothing but 2 into 2 into 2 into 2 into 2. So its value is 128. So I am going to divide this 128 with 33. So the quotient is 3. Divisor is 33. So I am getting the remainder is called 29. Okay, so the balance value is 29. Always answer is remainder value only. So we are finding the value of c only. So c is 29. Okay, so this 29 is left hand side value. Actually our message size is 2. Okay, now we'll come to right hand side part. Right hand side part, that is nothing but decryption. Decryption means we are finding the value of m. What is m? M is nothing but message. While we are doing decryption, automatically, I already told you the reverse procedure of encryption is called decryption. So the formula for m is c to the power d modulus of n. So already we know that c is nothing but 29 and d value is 3, n value is 33. Now I am substituting these values into this formula called decryption. So 29 to the power 3 modulus of 33. So 29 to the power 3 is nothing but 29 into 29 into 29. So that its final value is 24,389. Actually I am going to divide this 24,389 with 33. Okay, so I am getting the result of quotient is 739 and the remainder is 2. I already told you always answer is remainder value only. So in the encryption method also our message value is 2 and the right hand side, the decryption, here also the remainder value is 2. So LHS equal to RHS. Now we have been solved this Rse algorithm. That means even though the hacker is hacked our file, he may capture the file, but he cannot identify what is the content of the message. So he cannot understand anything from our message. So that is what we have been protected with our message. So by using the technique called encryption and decryption method. So my dear students, so it's a part C question. It is called Rse algorithm. Kindly take serious with this question.